Okay, we're going to start 6-3, vectors in the plane. Your I can statements are right here. You can represent vectors as direct line segments, components of vectors. You can do operations. We're going to write combinations, and we're going to find direction angles of vectors, and so on. Okay, let's move on. Okay, so the first thing that we need to think about is what is a vector? And if you remember back in geometry, we said a vector has direction and magnitude. And so that's right here where it says, hold on, right here, direction and magnitude. Okay, direction and magnitude just means it tells you which way it's going. So if you take a look here, it's going this way. Magnitude is how far did you go. So it's like your distance. That's why it's here. And I'm going to show you a way to find the distance, and an easier way than using the distance formula. So we always have an initial point, and then we have a terminal point where it ends. So, and then if you take a look here, all of these are equivalent because one, they're going the same way, and two, they all have the same distance. That's how you know if they're equivalent. And when you do a vector, you put like a small UV or a W, which means this is the vector. So the vector goes from P to Q, P to Q. All right, so we're going to do this first problem here, and it says show that U and V in figure 612 are equivalent. This is where I'm going to show you a different way to do this so that you do not have to use the distance formula. So if you think about this right here. It goes up how many units and over how many units? And this is a right triangle, right? So if we do Pythagorean theorem, which is a squared plus b squared equals c squared, we can find the distance of that vector. So I'm going to go back and let's put in our information. So it goes from 2 to 4, so this is 2. And then it goes from 1 to 4, so this is 3. So all we have to do is go 2 squared plus 3 squared equals c squared. So 2 and 3 is 4. So we've got 4 plus 9 and the square root, right? So the distance of RS is going to be the square root of 13, which is our velocity, our first vector, our vector 1. So this is how we're going to see if they are equivalent. So that's the distance. So now we're going to go to the next one. We're going to do the exact same thing. So I'm going over 3 and up 2. So this is 3, this is 2. So for U squared, right, we're going to go the square root, 3 squared plus 2 squared. So of course, U is also the square root of 3. So we know we have the exact same magnitude, which is a distance. So far we figured out magnitude. The only other thing you have to see if they're equivalent is what about their direction? In other words, what is their slope? So my slope here is I go up 2 over 3. So the slope here is 2 over 3. And the slope here is I go up 2 over 3. So the slope here is 2 over 3. Therefore, these two vectors are equivalent. Okay, go ahead and pause and show your work on the next checkpoint. Check in when you're ready to go. So U is equal to the square root of 10, which is the distance, and V is also equal to the square root of 2, which is the distance, that's its magnitude, and the slope for both of them is 1 over 3, which is actually their direction. They're going up 1 and over 3. Okay, let's talk about the components of a vector. So a vector, your initial point is always P, and your terminal point, or where it ends, is Q. So when you look at a vector, let's say we've got an initial and a terminal. What you do is you go from your terminal to your initial, so you just subtract them. That's going to give you your actual vector. And then magnitude, again, remember we said that's the length, and really all that is you're just finding the distance. So if you think about, like, if I have my vector, and let's say here's my point, v1 and v2, right? So this is my point. So I'm saying, how far over did I go? That's v1. How far up did I go? That's v2. So that's why if you look here, that's why the magnitude, which is right here, is you go v1 squared plus v2 squared equals, it's just Pythagorean theorem. That is always, since it's a distance, it's always positive. And if you have, like, your magnitude is 1, that means you have a unit vector. So let's move on to the next. Okay, so the first thing we're going to do is we're going to find our actual vector. Right now we have an initial and so our initial point is at 4, -7, and our terminal point is -1, 5. So to find our component, all we have to do is go v is equal to, and remember we go -1 minus 4, so this one minus that one, and 5 minus -7. So our component form would be -5, 12. So look, -5 up 12. Okay, now the next thing that we need to find is we need to figure out the magnitude. So again, this is why we're using that Pythagorean theorem. So what we're looking for here is we're looking for the distance of this vector right here. So if you notice, this is a right triangle. So since it's a right triangle, all we have to do is use the a squared plus b squared. So our magnitude is going to be the square root of a squared, which is -5 squared, plus b squared, which is 12 squared. So we end up with our magnitude, or our distance, equaling the square root of 169, which equals 13. All right, time for the checkpoint. Go ahead and pause, give the checkpoint a go, and then come back and see if you got it correct. Okay, so your vector here should have been -5, 6, and your magnitude, or your distance, should have been the square root of 61. Okay, next thing we need to talk about is vector addition and scalar multiplication. So vector addition means you're just going to add your two vectors together. So if you think about it, so I've got this vector and this vector. So what I'm doing is I'm taking that first one and then I'm putting this one up here and adding it to get this vector. Okay, the other thing is scalar multiplication, where it's kind of like you're just multiplying it by a, what do we do in geometry when you multiply it just by a number? So it's really like doing a dilation. Okay, let's move on. All right, here again, it's just talking about the negative vector. So if we have v, notice it's going this way, the negative vector would mean it would just go this way, right? And that's what they're talking about. So here you're just pretty much doing like a scalar multiplication. And then the difference, you're doing the same thing. It's like you're doing a scalar multiplication of them. So not that big of a deal. Okay, let's go on to a scalar multiplication. We're going to do a in blue. So if we look at where a would be, it would be at -2, 1, 2, 3, 4, 5. So this would be a, right? And if we do a scalar multiplication on that, that means we're just going to multiply it by 2. So we get -4, 5, which means it would go to, I'm sorry, -4, 10. Duh. So it would go from here to here. So what it did is it extended it to here. So that's A. Okay, let's go to the next one, and we'll do that one in green. So now we're going to take our W minus V. So let's go ahead and plot W first, and W is at 3, 4. So this is where we're at right now. And then we're going to subtract v, so let's go ahead and do that. So we've got -2, 5 minus 3, 4. oops, sorry, I got that backwards. Let's do it the other way. We're doing WV. Okay, so W is 3, 4, minus negative 2, 5. So we've got 3 minus negative 2 and 4 minus 5. And we end up with 5, negative 1. So 5, negative 1 is right here, right? So this is where B is going to end. It's right here. Okay, we're going to do the next one in red. So we'll do this one here in red. So we're going to plot V first, and V is at negative 2, 5. So here is where V is, which is this one here. Okay, and we're going to do V plus 2W. So V is negative 2, 5 plus 2 times your W. So negative 2, 5 plus 6, 8. That's a plus. So now we've got negative 2 plus 6. And then, oh, let me erase that real quick. Okay, go back. Okay, so we've got negative 2, 6, and then we've got 5 plus 8, and so we end up with 4, 13. So if we go to 4 and go up here to 13, this is where our C is. Okay, so go ahead and let's find the answers for your checkpoint. Go ahead and pause, and we'll go from there. You can come back and check to see how you did. So A is going to be, oops, redo this. A is going to be 4, 6. B is going to be negative 2, 2. And C is going to be negative 7, 2. All right, let's move on to the next one. Okay, so here's some properties of addition and scalar multiplication. It's pretty much the same thing that you've known before. The only thing that I would pay a little attention to is this one here. When you're doing magnitude, which is the distance, what you wanted to see is that when you're doing your scalar multiplication and you're multiplying by something, you're multiplying by the positive because it is a distance. Okay, so what we're finding here is the magnitude of each of the scalar multiples. And so if you remember, I said just pay attention. So if we take a look at A, that means we're going to multiply this one by the multiply 2 times the distance of U. So take a look at U. This is U. So we're going to use the Pythagorean theorem. So we got the square root of 1 squared plus 3 squared, which is going to give us a square root of 10. And we're going to multiply that by 2. So this is 2 square root of 10. All right, let's go to the next one. Let's do it in green. And the next one is this one. So now we need to find the magnitude again of U, and we know what that is, right? And so remember that we do the absolute value of negative 5 times the magnitude of U, and we already know that the magnitude of U is square root of 10, so this would be 5 square root of 10. All right, let's do this last one here. Now we're going to do this one here, so we need to do the absolute value of 3 times the distance of V. And again, if you look, here is V, so we're going to do the square root of 2 squared plus 5 squared. And we end up with the square root of 29 and multiply that, 29, multiply that by 3, so the answer is 3 square root of 29. Okay, go ahead and pause, give the other ones a go, and then jump back on when you are ready to check your answers. Okay, there's the answers. Now get ready to watch part 2. This is the end of part 1.